Here's our last problem, and it is going to be a Pythagorean relationship problem. But there's some kind of neat thing in this example that I want to make sure that you catch in here. We've got a police cruiser approaching a right-angled intersection from the north and is chasing a speeding car that's turned a corner. So I'm going to draw the roads here. And we've got the police cruiser. I'm just going to call him A. He's up here. He's headed in that direction. And he's approaching the right angle from the north. He's chasing a speeding car. We'll call that B. I'll put him over here. So we've got A up here, B over here. Speeding car is heading that way. And we've got some information there. When the cruiser is 0.6 kilometers north of the intersection, the car is 0.8 kilometers to the east. And we've got some sort of distance in here, and I'm just going to call that C, and we've got a right angle triangle. You guys can see this A squared plus B squared is equal to C squared relationship showing up there. So dA dt is going to be negative 100 kilometers per hour. And this is kind of the thing that I need you to get from this problem, is that when you're setting this up, if the dimension is decreasing in size as the distance is here, A, it's kind of shrinking down as he drives towards the corner, then we're going to use a negative convention here. B, however, is going to be growing, and we don't know what that is, but we do know that it is going to be when A equals 0.6, when B equals 0.8, and when C equals O. Okay, so we don't know C, we need to figure it out. So 0.6 squared, 0.8 squared equals C squared, and 0.36, 0.64 equals C squared. Add those together, and 1 equals C squared, so C equals 1. So that makes that kind of easy. So here we have the two rates. We're also given one other rate, and that's the rate at which C is changing. So dC dt has been told to us as 32 kilometers an hour. I'm going to call that positive because that distance is increasing and not decreasing. It's getting larger, not getting smaller. Okay, so I'm going to set the equation up. A squared plus B squared equals C squared. I'm going to differentiate both sides with respect to time. 2b dB dt, plus equals 2c dC dt. Now, I've got 2's all the way through. Every term has a 2. If we divide everything by 2, we get A dA dt plus B dB dt equals C dC dt. We're trying to find dB dt. So I'm going to say that dB dt is going to be C over B dC dt minus A over B dB dt. Okay, so that's our dB dt. And then finally what we're going to do is we're going to just plug everything in. So C over B. I think I'm out of room here. So I'll do it up here. dB dt when A equals 0.6, B equals 0.8, and C equals 1 is going to be 1 over 0.8. And we've got 32 minus, and A so 0.6 over 0.8, and there's negative 100. And if I plug that all into my calculator, I get 115 kilometers per hour.